Hello everyone. I hope you guys are doing well. Before watching different example on asymptotic notation, please watch this particular lecture. Interesting example of big O notation from your real life. Okay, so let's have an example. So here f of n is given, and we have a set of values in ascending order. So we have to find g of n for the upper bound and for the lower bound. 5n plus 4. This is your what? This is your f of n. So this is your f of n, and here I will write c g of n. But keep in mind, here we have two terms like 5n and 4. We have two terms, but here we cannot have. We should keep one term. So I can write 10n. The 10 is a coefficient and it's also called constant. This is the c actually. This is the coefficient, and this is your n is your g of n. So now I can write that this function, because if I put these values, in that particular function, like in this, so it will be always greater. Like I'm just giving you example. 5n plus 4 less than or equal to 10n. So I will put 2 first. So it will be 5 into 2 plus 4 less than or equal to 10 to 2. So it is equal to 14 less than or equal to 20. So the condition is true. So the condition is true. If I put 4 over here, and I can say 5n and n is equal to 4 plus 4 less than or equal to 10 into 4. Okay, so the value will be 24 less than or equal to 40. Okay, so again the condition is true. So same it is like if I put 5 and 7, so the condition will be true. So it means that 10n is perfect for the because it's satisfying the condition of upper bound. So it means that I can write big O of n. This function is the big O of this particular function. So I can represent it with the big O of n. Okay, so so here you can see that it's belong to this class. It's belong to this class. So here I can say that this is the upper bound. Okay, this class is the upper bound. But if I like here I have given you an example. So if I write 5n plus 4 and I write it 10n square. Okay, so again the condition will be true. If I put like less than or equal to 10 n log n, so again the condition will be true. If I put less than or equal to 10 n cube, okay, so again a condition will be true. So it means that all these functions belong to the upper bound class. So I can represent this function with the upper bound, or I can represent this relationship with the upper bound. So I can write big O of n, but condition will be n greater than or equal to n naught. If I put n log n, if I put n square, if I put n cube, up to so on, if I put all these values, it will be the condition will be true, and this function will be this 10n square or 10n cube or something like that. It will be always upper bound of this particular function. So I can write it that I can represent if I am using n square, so I can write big O of n square. If I use n cube, so I can write big O of n cube. Okay, so I can write like that up to so on. All these functions belong to the upper bound class. Okay, belong to the upper bound class. But I will add one important thing is here, that if like I have already explained that thing in the previous example, that for example, if you have f of n, this is your f of n. Okay, this is your f of n. So if you want to find the upper bound of that, so it should be quite close to that one. It should be optimized. Here you can write the 10n is more optimized. If I see as compared to n square and n cube and up to exponential function, this function is more optimized. This function is more optimized. So you will have to find the more optimized function. You can write, even if I put n square, n cube, up to so on, in exponential here, so the condition is true, the function is not optimized because there is a big difference between them. Let me give you an example. Like if I put 5n plus 4 less than or equal to 10n square, let's say I have this function. So if I put 2 here plus 4 less than or equal to 10, so what will be the answer? Less than or equal to it can be 40. So there is a big difference. So if the n value become 1000, 1 million, so there will be a very big gap. It will be going exponentially, and f of n will be linear. So function, try to find the very close function to that, to the particular f of n. Even though here the condition is true, still you will have to find the more optimized value. So I hope you have enjoyed this one. And if you have any question, you guys can ask me in the comment section.